Welcome everybody to the June JavaSIG. Come on in. Tonight we have Anna's going to talk about using test containers to test your GenAI applications with Docker. But before I turn it over to Anna, I know that Jean, you want to talk about the mentorship program.
Yes. Thanks. As we announced a month or so ago, we're trying out a summer mentoring program for the first time. If it's successful, we'll do it again. We had 4 applicants, so everybody got in, which made it super easy for us because we also have 4 mentors. So I'm going to announce the pairings here, which is the unveiling of it. And if the people aren't here, or if they are here anyway, they'll get an email. But you're here, so you get to hear the news in person. Barry is going to be paired with Kareem. Frank is going to be paired with Sarath. I'm going to be paired with Zarko, and Naya is going to be paired with Felix, and we will reach out directly about details and finding a time. Thank you.
Thanks, Jean. Okay, so before I turn everything over to Anna, does anybody have any open questions about Java or Java-related things that you have experts in the room that potentially we can answer? Any specific questions? Who's doing generative AI with Java?
Why there is var in the language?
Pardon me?
Why they introduced var in the language?
Why did they introduce var?
Yes.
Oh, there's a teacher in the room.
Doesn't it make code a little bit simpler if you have array list, string, this, that,
They
on
just,
the left side of the
yeah, it just helps with typing. Just helps with typing, so you have to do this huge thing on that side of the equals.
Yeah, if I found it would be strong typing language.
Yeah.
It's strong typing. It's
Yeah.
so strong typing language.
Not with the var.
It is.
No, yeah, it is, yeah.
Yeah, the
Yeah.
type inference is just as strong as back when var didn't exist in the language.
It's sometimes
Because type inference, it won't let you use var unless it knows what type name would be there.
Right. And you have to use it carefully. If the type isn't clear, you don't want to use it, but it helps with code like try input stream is equal new input stream. What do you think the type of this might be?
I know sometimes it gets difficult when you're reading code and you see the var there, and it's like
exactly. And I'm still having the question when you go in and change it back, like when people.
It's right, exactly right. It's just reading code.
It's awesome in Jupyter, if this kind of unstructured environment where you don't care about this code to survive the next couple of hours, then it's great.
Yeah, exactly. Any other questions?
See what it is.
Yeah, right. Well, that's what IDs are for, right? It's like.
But it's use it carefully. If it's not clear, isn't the place to use it.
Yeah.
Like in my example, you're gonna have to look up what type IS is.
True. That's true. All right. Any other questions?
I usually use Java compilers online, but how do you use the libraries that sometimes you need for some AI applications? I mean, in compile online, how do you really include that?
When you say compile online, what do you mean compile online?
You just say Java compile online.
Oh, command line. I'm sorry, a command line you meant.
No, like Java Playground, where it's bare bones.
The compiler is online.
Yeah, she means like Java Playground, where it's just a bare bones compiler. You need something more advanced if you're using libraries like GitHub Spaces, where you can have a build tool, so you can still be online. But those compilers online that advertises that are meant to just be the pure language. But you can still do stuff online. What you need is an IDE online and not just a compiler. Yeah. Well, and you have to if you want to use dependencies.
Okay. So yes.
And to your question, you asked that who's using Java to build a GenAI application. I want to know if anyone is using any of the frameworks available with respect to Java.
Like who's using what GenAI frameworks for Java? So first of all, who's using Java for GenAI other than me? Here we have someone over there. What frameworks or what are you using?
We're just starting. We're using Spring AI.
Okay.
We're just starting. We're just getting our feet wet with it. Various use cases.
Okay.
Kind of pilot things. Not yet. It's we control the chat. We're building our own chat and client for dedicated users.
Yeah.
So it's not hooked up to ChatGPT. So we're building our own chat client. they show me how to rebuild websites. So how do I improve a website or query my order data, show me like what type of stuff I do, or help me build a product catalog, stuff like that. We built our own shop. So there's no MCP yet.
Okay, but it's not, you're not using MCP yet.
No.
Okay.
We will like later when we get into like unauthenticated workflows and we start exposing it to the end users.
But it's moving so fast is that you have MCP, then someone says, oh, by the way, we have A to A. So what's A to A? Agent to agent. It's like, oh, okay. Then you go over there and he goes, oh, we have ADK. What's ADK? Agent Development Kit. It's like, okay. And this is happening like on a daily basis. Like, but I'm using LangChain4j, and you could use LangChain4j with Spring AI. I have a little beef with the Spring guys talking about Spring AI. I said, I kept telling them, and even Josh got mad at me for saying, I said, Spring AI is not AI. It should have been called Spring GenAI, because it doesn't touch the other aspects of AI. And he gave me grief about that online. But then I did talk to one of the founders of Spring, Rod. Rod has spoken to our group many times, and he agreed with me. So I said, good. So let me turn everything over to Anna. Anna, it's all yours.
Thank you. Nice to meet you all. It was actually one of my questions during the presentation, who is using what type of frameworks for GenAI development, because we will be talking about LangChain4j today. I can describe it a little bit more during the presentation. So let's go to the introductions. Yeah, my name is Anna. I am from Canada. I live in Ottawa since recently. We just moved to Canada recently. Yeah, happy to be here. I joined Docker with the acquisition of AtomicJar. This is the small company behind Testcontainers and Testcontainers Cloud. Now this is part of the Docker suite of products, and the open source part remained open source. Yeah, sometimes I post something smart or not smart on LinkedIn and Twitter. So yeah, if you want to get connected, I will be happy to. Okay, what we will be talking about today. So we will generally talk about GenAI development. What does the landscape look like today? Discuss how to test the deterministic part of the applications using test containers, and how can we approach the testing of non-deterministic parts, meaning the models, again with the test containers. Who is familiar with test containers? Good. I will still explain the basics, but yeah, we will use it today during the session. So the GenAI stack, we touched base a bit like during the conversation earlier, the Spring AI, LangChain4j. This is the frameworks that are used in generally for the application development. So the flow is like on the high level, can look like this. You have like the user that submits a prompt. Then your application can use the framework to talk to the language model. It can be an open source language model on the Hugging Face. It can be your model that you're developing in your organization. It can be the model from the vendor, like from Anthropic or from the OpenAI. But what framework is doing, it just unifies how to talk to the model, so you can switch between models pretty easily. Then there is the part with the RAG. In this part, you can ingest some information and provide it as a knowledge for your model. When models are trained, they have access to the information at the point of training. After that, they don't know what happened. So you can pre-populate the knowledge using the RAG to the model, or models can use the tools calling. Again, coming back to the MCP topic, that's kind of was touched base a bit. Applications can use MCP to do the tool calling. For example, if you ask any model what time is it now in New York, it will not provide the correct answer. But if you implement the MCP server that can call the API of get current time, the model can kind of use this tool and have the information about current time at the specific location. The challenges about testing are pretty simple. We know how to test the deterministic part. When we know what should be the answer, we know how to expect, and we can do assertions around it. For the models, we don't know what will be there. So this is not deterministic. We expect it to provide an answer in some way, but it can be like differently formulated depending on the model, depending on the training set, depending on the RAG that we use like as a knowledge base for the model. So this part adds additional challenge to the testing, but there are some workarounds, at least approaches how we can test it today. Let's go to the deterministic part first. So approaches for the deterministic part testing is kind of pretty established. You know how to test, let's say, AWS services. You can spin up local stack, which is the emulator of AWS. You can spin it up locally and verify the things. We can test applications like that use Kafka. Again, you can run the Kafka. You can use containers to run it and test your application. You can test application with databases. So kind of all of these pieces are pretty well established, and we can use test containers as part of this testing to speed this up and kind of shift testing a bit left to the developer inner loop. What test containers is doing, like what is this? This is a set of the open source libraries. They were born in Java, like it was the first implementation. And right now there are more than 10 languages that are supported with this library. It helps you to spin up real services in the Docker containers through your code base. One way how you can spin up like the database, like in this example, pgvector, you can spin up the vector database using test containers. It will be running for your test execution. When tests are done, the container will be destroyed. So kind of you can do the same doing like Docker, run, Postgre, provide host, port, and other details. You can define the Docker compose file where you provide information about the environment that you need for the testing. Or you can go with the programmatic compose, we sometimes name it this way, so that you use the language of your application, like that you use for application development, and define in the tests using Java what containers you want to start. Framework like test containers will tie to the test framework implementation, and it can understand when the test event was triggered. It will spin up the containers, then test will run. When tests are complete, containers will be automatically destroyed. So kind of automatic management of the environment that is needed for integration tests. And for GenAI testing, we can use it as well and run the vector databases with this. A little bit more about how test containers works. You add, it's probably pretty small in your IDE, so you just add the dependency and define the same setup. When you do like container starts, like let's say Redis start, the command will be interpreted into the Docker run. It will use Docker API to talk to the Docker daemon. The daemon on the host will go to the registry, pull the image that you provided in the description, pull it, start it, and provide the information about the container back to your tests. So in the code, you can manage the environment, you can manage containers, you can spin up containers, you can then ask container to give you the port that it used to start. Ask container to get your hosts, to get environment variables, multiple different things. Like we can discuss it during the demo part as well. So kind of pretty convenient way to set up infrastructure for testing. And there is concept of test containers modules that we will be using as well. The basic building block is generic container, and you can spin up everything that can be run as a container using generic container. the modules, they serve as a high-level abstractions around some specific technology. For example, Postgre, they just hide some implementation details of how you want to start the Postgre. So you just put in code that I want Postgre with this image, start, it starts. In the list of modules, there are like databases, cloud emulators, message brokers, and we added a couple of vector databases that can be used to spin up these types of databases for the testing if your application is using the vector database for the RAG. All right. With the deterministic part, like on the high level, it's pretty clear. We can dive deeper when it goes to the code. But how to test the non-deterministic parts and that the LLM responses are correct? Yes. For the demo example, we'll be using LangChain4j. LangChain4j is the framework. It's open source. You can use it to build the GenAI augmented application. It provides the easy switch between the language models, just the kind of generic API. It can help with embeddings. Who is familiar with embeddings? Okay, I have another slide about it. Yeah, so it can help with calculating embeddings, and it can help with talking to the vector databases and managing like the RAG for the knowledge base. Let's go to the embeddings. Okay, I am also like, I'm not a mathematician. I know how it's kind of implemented. I will not answer the questions about the mathematical aspects here. But from what I know, embedding helps you, like the embedding model helps you to convert the sentence, the semantic meaning of the sentence, of the text, into the vector. Then we can store these vectors in the database, in the vector database, and do the search in this database. There is also the term of Cassin similarity that can help us to compare two vectors between each other. Cassin similarity is measuring the angle of the vectors, not the length. So if the vectors are pointing in the same direction, the Cassin similarity, like the angle will be 0, Cassin similarity will be 1, so it means that they are identical. If they point like perpendicular, so the angle is 90 degrees, and Cassin similarity like will be 0, means that they are unrelated, they describe different things. And like the last, if they are pointing in the opposite way, means that they are kind of opposite, like completely different things. Here I have this example about a cat and a tiger. What we need to do to like run the embedding and do the Cassin similarity calculation, we need to have the embedding model that could kind of translate it into the vectors. Then we can embed these two sentences and calculate the Cassin similarity between these two sentences, like the semantic meaning of the sentence. They can be formulated differently, but the meaning will be kind of very similar. Here, the Cassin similarity is 0.59. Yeah, so they are kind of not that related, which is probably true. Like we are talking about cat and a tiger, they are similar, but they are not that similar. So this concept will be used during one of the approaches how we can test the replies from the models. And the next part is RAG, So embedding is also used in the RAG to store data in the vector data stores. So you can then use them for the search, and model can use it to generate the answer using this kind of knowledge base that is stored in the database. To do so, we need again the embedding model. We would need the embedding store. We will kind of put the data there, and when we create our service, we just define that we want to use like the basic model embedding store, and it will use the data that we put there. I have an example of this. We can run it also like in a couple of minutes. So kind of RAG just helps the model to provide the more correct answer to the questions because it has some knowledge. And for the data storage using RAG, like typically you frame like the knowledge, the data. You can put the like text files there, obviously, but the most kind of common approach is to form the data in more proper format for the models to understand it better. If you just put everything there, it will be harder to kind of translate and store it and then search. And how to run models. There are different approaches. Again, you can go with the vendor, you can go with the Anthropic or OpenAI, but you will need to pay for the cost of tokens of the model, and especially for testing, it can be pretty expensive exercise because every time you send data to the model, like you interact with this, you would use tokens, which is money. So there are some ways how to run models locally, at least for the testing purposes. The popular way was to use Ollama. You can, who is familiar with Ollama? This is kind of the runner of the models that you can download, you can run it, and then you can use it to run models locally. But this is another like additional tool that you need to have in your tool set for GenAI-based application development.
Yeah, this is another reason why. I mean, other than cost of tokens, there's security. When you're using OpenAI, using Anthropic, you're actually sending your data to them. So you don't want to do that. Yes,
yes, yes. For yeah, like most of the companies, yeah, that's risky. So yeah, having Ollama and like running models with Ollama adds additional tool to the toolset that is already kind of big, and every day something comes up about GenAI things. Yeah, I personally like scroll the LinkedIn and there is one post that, oh, this is the new tool. Then there is another tool. This is very good. Oh, I experimented with this agentic framework, and you're like, what is this? I don't hear about it before. Okay, so another new tool for your tool set, Docker Model Runner, but it comes already with the Docker desktop. So if you have the Docker desktop, it will be there. It is open sourced. It goes with the community edition. So even without Docker desktop, you can run it with the Docker engine if you run it on your servers. So kind of open for everybody. It serves the pretty simple purpose, just to be able to run the models and interact with the models. So far, it supports the language models, like not the models that can interact with like the images, but the language models. It can pull model, it can run model. You can also right now pull open source model from the Hugging Face, for example, and push it to the Docker Hub with the Docker Model Runner. It will be stored in the Docker Hub as an OCI artifact. So we kind of moving in the direction of being the storage for not only containers, but for the models, and make the experience of using the models locally as simple as using the containers. By the way, who is using Docker? Okay. Yeah, ask everything, but not about Docker.
Models are different kind of artifacts. It's not like a standard Docker
No, it's just an part of the engine right now that helps, like, can run models.
So they not running as containers, but accessible via TCP.
Yes. I will show probably like after the slide. Yeah, so you can run this and you can interact with the models. We provide open AI compatible interface. So if you were using models from OpenAI, you can use the same way of interacting with the model, but the model will be running locally. Let's go to the application and use cases, and finally go to the code. So the application that I have here is pretty simple, Spring Boot application. It uses RAG with this AtomicJar model, just some model, again, publicly available. It uses pgvector as a vector data store. LLM framework is LangChain4j, and I will be running everything with Gemma 3, but we can switch the model and see how they behave. The application is just an answer provider, agent, helpful agent that replies to the question. And I have the default question that I asked during the tests, like in Formula One season 2024, who won the Great Britain GP. The model, let's go here. Okay, there will be two scenarios. First is get the straight answer from the model, and the second scenario is get the rugged answer. For the get straight answer example, model doesn't know about races and kind of scenarios, what happened in Formula One in 2024. But the rugged answer, again, if we probably change to GPT, I think it would know, but the small model doesn't know this. The rugged answer will use the RAG to, with the knowledge for the model to provide the more correct answers. So we will be kind of testing these two scenarios, how model would behave in each scenario. And let's finally go to the code. So first, how to test? Is it define script? Okay. Let's go first to the models. I wanted to show you this. So if you're using Docker Desktop, there will be a new tab with the models. You can go to the settings. There will be beta features, and you can just enable it and provide the port for TCP connections. In this way, you can interact with the model using just the TCP. I pre-pulled a couple of models. I have small LM, I have Gemma 3, and I have this embedding model. I can run them directly from the Docker desktop and ask questions.
Question?
Yeah.
Is it possible to run it from like a remote location if I use Kubernetes?
Yes. It goes with the Docker engine right now, so it's with the community edition. I'm just showing like the desktop because it's more visual way, but you can use it with just an engine and on your servers. Okay, so yeah, it replied something, so you can kind of just chat with this. But the more interesting use case if you can use it in your application. Kind of here are the models, and again, just show quickly, if you go to the Docker Hub, there will be AI models tab that contains the list of the models that are available right now. I use Gemma 3 because it's more or less smart and not that big. If we take a look at llama, for example, there will be the size, and it's like that big. Not sure if my laptop will handle this. Yeah, so there are a couple of them. Oh yeah, Red Hat put it something, containerized models. Very good, I didn't know about it. All right, let's go to the IDE where I had it. It's here. First, the application. Let's go here. This is the basic implementation, the chat model. I provide here chat name and base URL to connect. And like this is OpenAI chat model. This is LangChain4j implementation, how we can interact with the models. I'm using OpenAI chat model because Docker Model Runner provides OpenAI compatible API to talk to models. Here I would need to put the base URL, model name, API key is not needed, and I kind of build it. This is part for the rug. We have here store, we have model, we have documents. I would be using the knowledge JSON file from here. It just contains information about the races of Formula 1 during 2024 with dates, like time, laps, where it happened, and some content, who won, with what results. Okay. In order to embed this data, we need to have this store ingester that will use the store, the model, and kind of put the data there. What else? And the embedding model, I will be using the same, like the embedding model that I pre-pulled locally. The same thing, I need to provide the base URL, model name, pretty similar. And for the store, for the vector database storage, I will be using Testcontainers. This is a Postgre container. This is the module that we can use to run the PG vector databases. It's fine. We have some music. Oh, good. All right. We have this module where we can provide the kind of image for the PG vector and say that this is compatible for the Postgre, just additional implementation to kind of make things work, and start it. Then we can create like the store, and we can get data from the container that we started with Testcontainers. So this is kind of how easy it can be to talk and interact with the containers from the code. This is the PG vector that we defined here, and we can get host from this container. We can get port, database name, username, password. So kind of the things that we need in order to connect to this database. Okay. And I have the getAnswer agent. This is the URL that we can use to connect to the model. It's just localhost because I pre-pulled it locally. Ports I specified as 1, 2, 3, 4. Engines, Llama CPP.
So Testcontainers is not gonna like abstract port for the model or anything like that. So because it's just like a static service on your machine. Okay, so it's not dynamic creating it.
Testcontainers would dynamically create the container. When I run this service, I will show in the Docker desktop that's like how it starts, how it terminates. This base URL is for the model
Yeah,
in
so
order
that's what
to.
I'm saying. So
Yeah.
model is kind of like
Model, yeah.
independent of your test.
Yeah.
Okay.
Yeah, so kind of test containers, it's for like databases, message brokers, yeah, for the deterministic parts. This part, like the models, is for non-deterministic things. I have here the URL, model name, we'll be using Gemma 3. Question, who won the Great Britain Grand Prix? Oops. And I have this get straight answer implementation. Let me do like this, so it will fit on the screen. It will create the chat agent. Chat agent looks just like this. It has the system message that describes what it should do, helpful assistant, task is to provide the clear answer to the question. It should be maximum 3 or 4 sentences, so kind of just the prompt how this agent should work. Okay. In straight answer, we will use this agent with chat language model that we just defined, that will use model name and base URL to use the model that is pulled locally. And for the rugged answer, pretty similar, but there will be this line of the content retriever. And this is the content retriever that I just showed, that will use embedding model and embedding store to repopulate the data about Formula 1 races there. Let me do this bigger. Okay. So when it's run, we can actually run it here. Let me do it smaller and go to the containers tab. This is, okay, so you see this is test containers implementation. It started the reuse. This is resource reaper that will just delete the PG vector when execution is complete. It will live there for a couple of minutes while we are going to see the answers. When we go back, it will be deleted. So the answers, this is the rugged answer that Lewis Hamilton won. This is the correct answer. And the straight answer will be, yeah, the straight answer says that Max Verstappen won. The model just decided to answer this. It doesn't have information about the races. Let's go back to the Docker desktop. Yeah, containers are not there anymore. This is the just standard behavior of test containers implementation. Let's go to the testing. How we can test? First approach, very simple, very straightforward. Maybe not that, let's say, production ready, but still, if the model reply should be, like you expect it to be very small or contain very, very specific things, we can just use this contains from the answer and see kind of how it behaved. Let's run this test. They will again populate the straight answer will just talk to the model and get the answer, and rugged answer will spin up the Postgre container. Okay, so the straight answer just failed, again, because it contains Max Verstappen, and the rugged answer was correct because there were Lewis Hamilton in the answer. Yeah, Lewis Hamilton. All right, This was very simple. Let's go to more complicated example. We can use Cassine similarity that we touch-based before to compare the responses with the expected answer. So here we can have the reference response, and in the reference response we can kind of have it as an embedding in order to run the Cassine similarity, and say that we expect the answer to be like with this semantic meaning. It can, like, the model can reply a bit in a different way, but the semantic meaning should be the same, that Lewis Hamilton won. The more kind of real-world example is probably if there is some educational system and students need to answer the questions, you can run the answers with the defined answer that, like, obviously is correct, and compare their answers between each other using Cassine similarity. So when you know what should be the reference response, when it's very strictly defined, you can run this, and it can be, like, for the most use cases, good enough to provide, like, the testing. So in the test, again, we get the straight answer. We put it into the embedding here, embedding model, embed straight answer. And then we do the Cassine similarity between the reference and the current response. In assertion, I put that I expect similarity to be more than 0.9, meaning like 90%. This is not the strictly defined value. It's probably defined, again, based on the couple of test runs, how model behaves. I just expect that 90% should be good enough. Same for the direct answer. We get the direct answer, we convert it to embedding, and then compare, like, run the Cassine similarity between two of them. Let's run this test. So the straight answer will be fast. We are not spinning up any containers for this. And the direct answer will wait for the embedding data store. Okay, and it passed. Let's take a look at the logs. What was the Cassine similarity between them? Okay, the first answer with Max Verstappen, Cassine similarity was 0.8. So they were close, but not close enough. And for the direct answer, yeah, it was 0.93. The model replied not exactly as we placed it in the reference, but again, the semantic meaning of this was very close.
How did you come up with the 90% as the threshold?
Just experimental things.
And when you say that 90% is like use case specific, because like it's more like the tolerance level of the application you're working on.
Yeah, yeah. Like if I put one, they would definitely not be the same. But if I expect, like if there is some system when I expect the completely the same answer as the reference, there should be one. So as closer the answer should be to the reference one, the higher should be the percentage.
And I will also assume that the reference embedding you made was just a without content, and the response will go as a whole sentence. And it might be that because we have great written GP in there, that's why the process similarity was so close.
Yeah, like the semantic meaning was the same. So kind of the model said the correct answer, but added some additional things here, like with the race lasted 52 laps. We don't have this in the reference response. Yeah. just July 7th for Mercedes. This approach can be used also not only for like the model testing, but if you want in general understand if models hallucinate, it can be also kind of good enough to understand if there are no hallucination in the answer from the model. It just didn't reply with completely nonsense comparing to the reference. Like in this point, the percentage of like how close the answers should be can be lower.
So I'm trying to understand the use case for testing. Because in the end, you're testing a limited model, not the actual one. And the goal is what, to see what's going to be the model response.
To see that the model replies as you expected it to reply.
Or if it's not the same model, why is that valid?
Like it ideally should be the same model that you expect to deploy to production. So I just use the Gemma 3 because it's available and it's easy to run. If like imagine that my company is building the models and data engineer give me a model saying that this is what we want to deploy to production, I should replace Gemma 3 with this model, pull it and kind of test it against the real model.
Have you seen this approach of OCI compliance containers being used to do evaluations, as you mentioned, hallucination, like monitoring hallucination? Have you seen that being used before?
You mean the models to verify the hallucination?
The responses they are given to.
Yeah, this is actually the third approach of how we can test the models. We can use another model to test the replies from the model under development.
Yeah, but it looks like the straight answer was a hallucination, because initially it was completely wrong, right? So
yeah.
You made up the answer, and the similarity was still like 80%, so it was still pretty high.
Right? I would say that like this is again like the demo example. When it comes to the real world, you kind of need to run a couple of examples and see like manually how it replies, and then understand what should be the percentage that is allowed in this case in similarity.
Basic testing, but in the real world, you need a lot more.
And like obviously for the complete testing, like there will be not just 2 test cases, there will be more, and then there will be another problem with the scaling, how to run models for like if you have even 100 tests that should interact with the model, you need to have the infrastructure to run all of this, and this is kind of another topic for another talk. Okay, let's go to the third example. Yeah, I have it here. Use an evaluator. So we can use LLM as a judge to verify the answers from our model that is under development. The thing here is that you need to define the strict prompt that would say like that your validator, very strict instructions, reference examples, what do you expect from this validator, how to behave, and like the detailed format in which you expect this validator to reply. It can be like JSON format where you expect some fields to be present. And kind of say that the agent can verify with yes or no or unsure based on the like reference comparison. So in this example, I will be using the format of the question that we're asked, answer that we get from the model, and kind of the reference for the validator saying that the answer should be should indicate this. Let's go to the example. Let me show you the agent first. Here is the set of instructions. You are strict validator. You will be provided with the question, answer, and the reference. You need to assess if the question, if the answer is proper for this question. reply yes, no, unsure, yes if correct, no if incorrect, unsure if you're unsure. Then the format that we expect the JSON as a response. In response, we expect to have like yes, no, or unsure, and the reason. We ask model to provide the reasoning why does it think that the answer is incorrect. Examples is like the question, is Madrid the capital of Spain? If the model says no, it's Barcelona, then like we have the reference that the capital of Spain is Madrid, then we expect the response from the validator no, and the reason the answer is incorrect because the capital is Madrid. Yeah. Yeah, and the user message that we will pass to this validator agent. All right, here we have the same question. The validator, the reference answer must indicate that Lewis Hamilton won. In the setup, we will set up the validator agent in the same way as we were doing for like the model under the test. Probably the model can be different, like the one that you really trust. So it can evaluate the results properly. But again, something that is running locally is fine as well. In the test, we get the straight answer. Then we ask the validator agent to validate. We provide the reference, provide the question, the straight answer, and the reference. And then we can do just a simple assertion that we expect yes in the validator response. The same for the rugged answer. We get the answer, we put it to the validator agent, and we expect yes to the validator response. Let's run these tests. These tests will be a bit heavier because we run the validator agent for each test. So, okay, the straight answer was actually pretty fast. And the rugged answer, again, we need to wait for the vector data store to spin up with the knowledge that we provide to the model. Okay, we have the PG vector, it generated the JDBC URL. Every time, like if you notice, the port will be different because test containers use the random port every time they spin up the container. Okay, the straight answer failed, the rugged answer passed. Let's take a look at the example. The straight answer, Max Verstappen, and validator response no, reason, the reference states that the Hamilton won, but it was Verstappen. And the rugged answer, yeah, Lewis Hamilton, and validator response, yes, the answer is correct because we were expecting this. So this approach with LLM is the judge, probably the most common one that we are seeing right now. It requires the model for the validator to be running somewhere. Again, if it will be something from OpenAI, it can be potentially expensive. If this is the model that you can run locally, it will be kind of the perfect scenario for the validations. And one more use case. Before we were talking about the positive test scenarios, we were testing that our model doesn't hallucinate, it replies properly. But with the models, it's usually very common for them to hallucinate, provide different answers. And if you want to test how RAG worked, again, model can provide different answers. If you're using OpenAI, you can run out of tokens, the service might be unavailable, etc. So kind of if we want to test how our application would behave in these scenarios, we can do a couple of things, and we can mock the model. Because this is just a REST API, when we talk to the model, we are calling the REST API. We can mock this REST API with the way we love to do mocks, I don't know, like wire mock or just something embedded. I will show example with the microx. So kind of if we make the model response deterministic, we can test the edge cases and we can have the better test coverage for the application in general, because we can emulate the model replies. So the microx, we have the implementation for it with test containers. This is just a container that can spin up things using like based on the open API specification. It can use like GraphQL as well, but for the open AI, it's important not to mispronounce them. I usually mispronounce open AI, open API. Everything is about AI. Yeah, so if you have the open API specification for the service, and we have one for OpenAI, we can mock it. We can emulate that model replies with completely nonsense, similar to what we expected answer, but not that correct. If it replies too slow, returns completely different things, or we run out of tokens, like multiple scenarios. How we can do this? Again, using the same application, not that real-world example, but we can validate that the validator agent is assessing the answer properly, emulating the responses from the model under test. In the microx, why I choose microx, it provides more flexibility with the mocks, and it's kind of easier to use. You can use dispatcher and use the script as a dispatcher to define the rules based on what rule, what answer should be provided by the mock. And again, having the open API specification from the OpenAI models, we can basically define what do we want the model to reply. Let's go to the example here. I have this mocked specification that uses the script to dispatch different rules based on the question. I expect if based on the request, I'm sorry. If we'll be providing the GPT-3.5 Turbo in the request, I expect to return the valid response. If in the model name we will provide the hallucinate, I expected to provide the hallucinated response. The correct response is like, yeah, Lewis Hamilton won, and hallucinated response that Lewis Hamilton won Galaxy JP used for the USS Enterprise team. It kind of still states the Lewis Hamilton, but the team and general competition is hallucinated. How we can test this? We have the question, we have the reference for the validator. We spin up the mock using microx, where we provide the image that will be used to spin this up, and the specification that I just showed, and I add a couple of logs just in case we need to debug something. In the initial setup, we can get the microx URL from the container in order to connect to this service, and then we can use it to kind of emulate the responses. We set up the validator agent that would validate the mocked responses, the same way we did in the previous scenario. Again, the test the correct response. We are using the same get answer agent with the same syntax. Nothing changed in the application implementation. We just provide the microx URL as a URL to connect to it. It will be mocked URL, and provide the chat name GPT-35. So in this use case, microbes will provide the correct answer and validate the response that we mocked. Test that model hallucinates. We provide the microx URL, chat model hallucinate, and we expect that validator will say no, because this is the hallucinated response. Let's run it. So we need to wait for the macrox container to start. Okay, here is the connection for the microx. We had an answer, and yeah, tests passed. So our validator agent properly worked. The correct answer was correct, and there should be some logs for this. Yeah, and the hallucinated response also worked properly. The response was no from the validator, and they said that answer is correct because it was, yeah, like about the Great Britain GP Grand Prix, but not the Galaxy Grand Prix. Okay, I think this is pretty much it that I have for today. Yeah, so we kind of covered 3 positive scenarios of how we can test the models, and the mocking thing. I think that the thing with mocking the models would get more popularity right now, because in general, when it comes to GenAI augmented applications, the behavior of these applications sometimes can be unpredictable, and it's hard to test how the system would behave when the unpredictable situation happens. With mocks, you can be sure that your application will behave as you expect it to behave. Yeah, thank you.
Thank you. Thanks, Anna. Any questions?
Is that proprietary to Docker? I was using another one, like Rancher. Would it work similar?
Docker model runner?
Yeah, Docker.
It will.
That's a proprietary feature of Docker.
Yes,
right?
yes, yes.
Any other questions? Okay, thanks again, Anna.
Thank you.
Thanks, everybody. We'll see everybody July 10th, location TBD. Cross your fingers.
Does anyone not have an IntelliJ license that wants one?
Yeah, who doesn't have an IntelliJ license?
We got 2. That's 2.
I'm working on community.
So I'm sure you guys can log on to info.javasig.com and we'll email you.
So we have 2 people that don't have a license?
Or an expired
Okay. Okay.
I'm friends with Sergey, so I guess you.
Oh, yes.
I'm the first investor in AtomicJar.